Welcome, business community. If you want to implement artificial intelligence system in your business, we are going to talk today about large language models, or LLM as they are called. Now, an LLM has an easy task: communicate with you so that you as a human have the impression that you are talking with another human, or that you are texting with another human. An LLM model has a lot of theoretical possibilities. You could use it as a personal email reply system, as an information distribution system to your customer. You can send out individual offers to your individual customers. Or if you have a call center, you can have an artificially enabled call center for the communication with your customer directly on the customer interface. Now, you might say, hey, LLMs, they sound cool. We have to have them. But let me give you a short overview about the definition, the current limitation, the state of technology we are in May 2022, and what I would recommend from a business perspective. So at first, the definition. An LLM is more or less a natural language processing system with more than 100 billion parameters. And it has a simple task: generate creative text. And this is easy because you just take a lot of data, you let the neural network, maybe a transformer-based, learn all those data that you provide to the AI system. And then you want the AI system just to mimic what it learned, the human conversations. Now, you are familiar maybe with GPT-3. This is from OpenAI, and it was called the hottest thing in town in artificial intelligence. And this was about 2 years ago. But then suddenly they discovered that GPT-3 generates a lot of toxic language, full of stereotypes and of harmful bias. And now, please do not make the mistake that the model generated this, because the model just mimicked what it learned. And as I already told you, data are so important for AI. And here we have the case where, to train such a huge system like GPT-3, the researchers had to look for a huge amount of freely available text, mimicking human conversation. And as I will show you later, there's something like the pile and other data sets. But you can also refer to publicly available data set, let's say on Facebook, or data set with Reddit, all the comments on Reddit. And now you understand the problem. Because now suddenly you learn the system not only on the textbooks in mathematics, on physics, or philosophy, or medicine, or law, but suddenly you have human conversation that is the topic that you want to understand, that you want to mimic when humans have conversation on Facebook or on Reddit subgroups about US politics, about Democrats and Republicans. And they have a very colorful language sometimes, and they use some words you would not like to have in your business conversation. So it is not that those models are somehow misbehaving. No, they were just looking for the data to train the model, and the data that were available was the human conversations, the conversations we have between us. And within, embedded in our conversation, is of course not only the most intellectual wording and the most heroic topics, but sometimes very, very emotional discussions. And the AI system also learned this. Now, of course, there are competitors in the industrial landscape, and we have here Meta, formerly Facebook, and they say, hey, we have a system that's at least as good as GPT-3, and we call it the Open Pre-trained Transformer Model OPT-175B. Now, for you, if you want to apply it commercially, the system, you can ask, hey, is there an open access? And it's no and no for both cases. But let's have a look at the second case a little bit more in detail, because on May 5th, 2022, Suzanne, Rolla, and Naman at at meta.com published an archive preprint here called Open Pre-trained Transformer Language Model. And they more or less give away the code and the training scripts if you want. So they open source their model to the research community. And you will understand in a second why. But let me just highlight one part of a sentence where they specify the compute infrastructure that they used to train the model. And as you can see here, they used 992 GPUs, and not the simple sort, but the NVIDIA A100 in the 80 gigabyte version. So let's say wherever you are in the world, it depends, between 15,000 and 20,000 euro or dollar per GPU. So you're looking here at a price tag between 15-20 million just for the graphic processing unit. We are not talking about the interlink, about the network, about the supercomputer infrastructure, about CPU, about some data. No, this is just to give you an idea why there are only a handful of global players that are able to develop those methods, and why it is so difficult for the research community, for a university, to come up with the money to be able to at least afford the infrastructure for it. And we are not talking about a specialist who are able to program those systems. Within this document, there's an interesting sentence, and they say they limit the access to their system only to the research community. So we have a non-commercial license. So they do not feel that it's ready enough to be commercially deployed, this system. So let this be, I don't want to say a warning, but just be aware that even Meta says, well, I don't think we are ready yet for a commercial application. But of course, they're working on it, and they do have the financial resources to push ahead. There's a complete other idea or industry behind this I would like to mention. And this here is an article from Nature, April 28, 2022. How language generation AIs could transform science. Because, there's an ongoing discussion between university and scientific publisher, the global publishing houses, that they publish scientific journals. And it is very, very expensive for universities to get a license from them for all of their students. And so in order to cut costs and maybe even increase profits, those publishing houses could rely on LLMs for finding peer reviews, extend the process of review to evaluating maybe the manuscript, or if you are in a position to provide grants, public grants or private grants to university research groups or whatsoever, maybe even it is there that LLMs can find an area where they are applied to analyze thousands, 10,000 of applications for financial support doing research. And this is not just limited to the US or Europe or Asia, wherever you are on this planet. And one of those recommendations from this article in Nature is because those LLMs, they are trained on data from the past. Whatever they trained on, it was at least a year old, maybe 2-3 year old information. So if you provide now an application for a physics grant, for some complete new IT infrastructure, for some new technology, how should an LLM be able, being trained on the data from the past, 1, 2, 3 years old information, to judge on a grant on an application about a technology that will be available in 3 to 5 years. So they say, careful, watch out. Those LLMs are likely to be too conservative in their recommendation if they would be applied to those aspects of evaluating or granting within the scientific community or within the public resources. So therefore, if you think about the AI revolution, I think the AI revolution is here and is ongoing. And if you want to have some more information, if you want to have a personal deep dive, I have 4 videos I would recommend to you. The first one here is about the pile. The pile is a data set where those AI systems are trained on. Currently it has 800 gigabytes of data. And the next line shows you NVIDIA's Selene. This is a supercomputer center by NVIDIA, which applies the A100 GPUs. And if you want to know a little bit more about current NVIDIA supercomputer center, this is the video for you. And if you think that the large language models are currently limited to 200 billion parameters, well, surprise, surprise, there's a Megatron LLG with already 530 billion open parameters in the AI model. So you can imagine what will come up in the next years and how many companies will be able to participate in this innovation pushing forward. Now, of course, there is also some Python code I provide to you here on GPT-J with a 6 billion free parameter model. Of course, I have only access to limited resources, to academic resources, so no way I have access to 530 billion capacity. So I do it on a 6 billion models and I show you the code. And of course, there's another video where I talk about avatar technology. If you use an LLM to empower an avatar, this is an easy thing to do. Because what you can do with vision technology and what you can do with speech recognition and LLMs, if you combine this and surprise, surprise, video, NVIDIA is interested in this topic, there's a video on LLMs in those upcoming avatar technologies. And of course, if you want to get a little bit into the coding of those systems, there's another video here, the yellow one. I have the GPT Neo 1.3 billion, so a very, very small LLM. It's not an LLM, it's an LM because it has less than 100 billion parameters, free parameters. And I show you how you can optimize even small system with a beautiful discovery by some scientists. It's called nucleus sampling, where you can optimize your vocabulary structure. This means the atoms that the system learns upon. So for a recommendation for a deep dive, I say thank you for listening, for watching this video. I will see you in the next video, but before I leave you, please don't forget, prepare your life for artificial intelligence.